Good evening, this is Miss Webb. I'm going to record this presentation because I'm very concerned about the Wi-Fi, especially during sixth period. And my Google Meet recordings are not going so well. But I'm going to do this evening. Normally, if I was going to do something like this, I'd try to do it all on the weekend and put it out there. So I'm going to try this with one shot and see how it goes. So our objective with the very first lesson in Module 1 of Eureka, the first thing we're going to do is we're going to review and recall polynomial terms. Okay, and I have no idea who you had for Algebra 1. I don't know how far you got, so some of you might be bored. But I need to go over this because this is something we're going to use all year. Polynomial terms. Poly means many. Nomial means names or terms. It's made up of a sum of terms. This is a polynomial right here. 9x to the fifth plus x squared minus 3x. It has three terms. They're added, or it's a sum. This could be seen as a plus negative 3x. Okay, and guess what? This is also can be considered a polynomial. It's actually another word for it is a constant, but it works. Okay, these are not polynomials. If you have a negative exponent, it is not a polynomial. If you have a fraction as an exponent, it is not a polynomial. Or if you have something like this where it's raised to the y power, it is not a polynomial. So when I go over things, I try to go over and show you what things are, and I try to give you an example of things that are not. Okay, so a polynomial is made up of a sum of a finite number of terms where each term is the product of a coefficient and a variable raised to a non-negative integer. So I'm going to go over each of these with you. Okay, so the terms, here is first term, second term, third term, and fourth term. Okay, those are the terms. Where each term is the product of a coefficient. Let me get a different color here. Let's go with purple. Okay, so a coefficient. The coefficient on this term is 9. Okay, the coefficient here, guess what? It's the number 1. It's an understood one. The coefficient here, it's not 3, it's -3 is the coefficient. And this one right here, it does not have a variable. It's called a constant. You know, we normally don't call this a coefficient, but that would be the constant. Okay, it says then you have a variable raised to a non-negative integer. So let's go pick a different color. I'll pick this orange. So here is your variable. It's x. It's x. It's x. This one doesn't have a variable. Well, I'll tell you a secret about that. You could actually think of this as being x to the 0 power, because anything to the 0 power is just the number 1. Okay, so that's how they kind of get away with that constant being in there. Okay, it's raised to a non-negative integer. So I'm going to get my green color. So there's a 5 there. It cannot be, oops, I need to be a highlighter. Cannot be a -5. Gotta change my color again. It's the number 5. The number 2. This one right here, it's an understood 1. And this one, it's a 0. So do you see how we kind of have this little treetop here? Starts at 5, goes down to 2, goes down to 1, goes down to 0. That's what you call in standard form where the highest power is first. A name is based on the number of terms. If you have one term, it's a monomial. 2 terms, it's a binomial. 3 terms, it's a trinomial. And we have some special names, like if it's a trinomial, we usually call it a quadratic. And I'll show that to you as we get there. Okay, the term degree. The degree is based on the powers. You can have the degree of a given term or the degree of the whole polynomial. So right here, if I have a term like 3x squared, okay, the degree of that term is 2. But if I have the degree of a polynomial, so polynomial, let's put a couple of guys in there. 3 plus 2x squared. Okay, the degree of the polynomial, I'm going to take the highest degree, which would be 3. Okay. Okay, so I'm going to ask you a few questions. Like, well, what's the leading term or the leading coefficient? If I looked up here, the first thing I'd say is, oh, it's 3. It's 3, Miss Webb. No, because you have to put it in standard form. Standard form means that it has to have the highest power first, and it's got to be like a little, like a slope of a, you could think of a roof, okay? We don't have any roofs like that in New Mexico, so it may take a little while to you guys to get used to that. But I'm going to go over, because it's kind of hard for me to do this with my mouse, I'm going to go get my little tablet so I can write. Okay, so I need to put it in standard form. So the highest power is right here, the 5. So I'm going to put that first, 3x to the 5th. What would be the next highest power? There's no 4 here. So I'm going to go to 3. That would be a plus 3x cubed. Okay, is there a 2 squared? Yep. Okay, now I'm not going to put 8x squared. I'm going to put negative 8x squared. And then here comes my caboose. So now I can answer the question, what is the leading term or the leading coefficient? It's 3. Okay. And it has 4 terms. The degree of the polynomial is 5. Okay. Let's go to the next one. Okay, so I want you to look, this is the very first lesson we do in Eureka. And on this one, I'm going to ask you to do the opening exercise. In other words, I'm going to go over to the next slide. In your classwork, you have these numbers, okay? And what I really want you to do is I want you to pause my video right now and tell me and see if you can see a pattern with these numbers. So everybody put it on pause and tell me if you can see the pattern, and tell me, can you fill out this last row here? Can you tell me what it is? I should have the little Jeopardy. Do, 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 do. Okay. Okay, when you come back, when I look at the numbers in this column here, let's see. I do notice there are 2, 3, 4, 5. I'm betting on this one being 6. Now, when I come and look at this one, I'm like, okay, did they add 2? But I don't add 2 each time. Well, wait, I could multiply times 2 to get to 4, but 3 times 2 would not be 9. But I start to see, wait a minute, I know my squares. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 would be 36. Okay, now how in the world did they get these numbers here? If you look at them for a while, hopefully you'll notice that 9 minus 4 is 5. 16 minus 9 is 7. 25 minus 16 is 9. 36 minus 25 is 11. Okay, I'm not going to do this one. I'm not going to do 36 minus 25. Can you see the difference between 5 and 7 is 2? Difference between 7 and 9 is 2. 9 and 11 is 2. I'm willing to bet that this one's 13. Is that the difference between 36 and 25? Well, that's where the 11 comes from. But my next one's 49. The difference between 49 and 36 would give me that 13. Okay, look at all these. 2, 2, 2, 2, 2. Where are they getting that 2? Well, look, the difference is always 2, so I'm going to say 2 here. So that's kind of the pattern. So I'm going to go to the next slide and show you a little bit about that pattern. Okay, so if you think of this as a function, and if you put x is equal to 2, 3, 4, 5, and if x is equal to 2 and you square x, you get the 4. Correct? Okay, now we decided that these were differences. Okay, right? 9 minus 4 is 5. 16 minus 9 is 7. But I want to show you something a little bit. So think of this as a table. And if you were thinking of this as a table, and maybe think of the difference here as a 1. Difference here is a 5. Difference here is a 1. Difference here is a 7. Okay? So I want to show you this in the sense that if this was like a function, what I might think of is the slope. The slope is always constant. The difference is 5, 7, 9, 11, 13. And the change, the rate of change, is always constant. It's always 2. Okay? It's always 2. So do you notice it's always 2. It's pretty cool. Okay, what we usually name these, and I'm going to show those to you, is the first difference and the second difference. Okay, so the first difference is when I go and take the difference between 9 and 4, 16 and 9, 25 and 16. But I'm also looking over here, these were all 1s. So I'm thinking I'm going to have to divide it by 1 as well. Then these, 7 and 5, these are all the difference is 2. Okay, so we call these, well, this is the first difference I see. This is the second difference that I see. I'm going to come over here. Okay, I'm going to bring up this little function notation here, which you haven't seen in a long time. I don't know. F of x is equal to 2x plus 1. And here's my little table here. I'm going to do this. And I'm going to say if x is 0, I'm going to go plug in a 0 for x. And what do I spit out? I spit out 2 times 0 is 0. 0 plus 1 is 1. If I put in a 1 for x, I get 2 times 1 plus 1. I get a 3. How did I get that 5? Well, 2 times 2 plus 1 is the 5. This one, 2 times, I put in a 3 for x plus 1, and I get a 7. 4 times 3, 4 times, what am I doing? 2 times 4 plus 1, and I get a 9. Okay, do you see how I got those? Let's do the first difference. These are all a difference of 1. So I'm good. I'm going to say, okay, 3 minus 1, the difference is 2. Let's see, 7 minus 5, the difference is 2. 9 minus 7, the difference is 2. What's the second difference? What's the difference between 2 and 2? These are 0. So 0. There's no difference between this column here, so the second difference is 0. Okay? So just follow me along with this while we find our first difference and our second difference. But I want you to tell me, what is the degree of this polynomial? The degree of that polynomial is a degree of 1. And if it's a degree of 1, do you notice the first difference is constant, second difference is 0. Interesting. Let's try a different one. This one, I'm not going to have numbers. I'm just going to call it A and B. I'm going to do it with variables. But I am going to do this with X here. 0, 1, 2, 3, 4. So I'm going to say if I put a 0 in for X, if I put a 0 here, that would be a 0 plus B, leaving me with B. If I put a 1 there, okay, A times 1 plus B, I'm going to get an A plus B. Here, if I put a 2 in for X, I get a 2A plus B. I think I can do this. 3A plus B, 4A plus B. So I'm doing the same thing of plugging my value of X over here, but I'm doing it with variables. So can you tell me what the difference is between B and A plus B? The difference is B, isn't it? No, it's not B. The difference is A. Right? A plus B minus B leaves me with A. Okay, what about 2A plus B minus A plus B? Let's see. Now I'm going to get into, let's see, 2A minus A, I'm going to get a 1A. Right? 2A minus 1A up here. The B's minus B, they cancel. What about this one? 3A minus 2A, and the B's cancel. Gosh, I'm getting all constants here. It all comes out to A. What's the differences here? Well, the difference is 0. A minus A is 0. The first difference is a constant. Second difference is 0. And what's the degree of this polynomial? The degree is 1, because that's to the first power. So I was trying to show you that even if you do it without numbers, I just do it with variables, I'm going to get a constant on my first difference, and I'm going to get a 0 for the second difference whenever the degree is 1. Okay, now I'm going to do one more. On this one, I jumped ahead of myself. I found this, and I know this is 0, 0, 0, and I'm going to say that you can deduct, and they write it kind of fancy, the sequence of a polynomial to the first degree. So remember, first degree, this is a 1. The power is to 1. An understood 1 right there. We're in n plus 1, n plus 2. So I'm going 0, 1, 2, 3, 4. The first difference is A, a constant, and the second difference is 0. And that makes sense because if it's to the first power, it's a line. And don't lines have a constant rate of change? And the difference or their slope is constant. You get that constant there. Okay, I'm going to go to example 2, but I'm going to take a break because I'm going to break this into 2 different videos. So that was part 1.